we're tackling find first and last position of element in sorted array. And we want to try and solve this with very strict time complexity of O log n and space complexity O1. In our problem statement, we're given an array of integers nums sorted in non-decreasing order, and we need to find the starting and ending positions of a given target value. If that target is not found in the array, we're going to return the pair -1, -1. And once again, the goal here is to write an algorithm with O log n runtime complexity. So there are 4 methods to choose from. You have A, 2 pointers, B, linear search, C, binary search, or D, hash table. I'm going to pause for a couple of seconds while you think about the choice here. And for those of you who are able to get this, congratulations. And for those of you who just want to see the code, the answer here is C, binary search. Every time we're given a sorted array, that really is our first thought. Anyway, the brute force approach I won't go into in too much depth. Essentially, we'd be iterating through the array, finding the first and last occurrence of the target, and then returning the indices at which we found it, if we find it. In any case, an ON complexity isn't going to cut it here, so let's take a look at the optimized solution. Now, in our optimized solution code, we're using the equal range function from the C++ standard library, and this efficiently finds the range of elements equal to the target in the sorted array. There's a really nice resource here which I'll include in the description to this video that explains how equal range works, and it gives quite a comprehensive explanation of what it's doing. So in essence, the function is returning a pair of iterators representing the lower and upper bounds of the range. As you can see, we subtract the beginning iterator of the nums vector, and by doing so we can obtain the starting and ending positions of the target if it exists within the array. So, if not, we're returning -1, -1, and there are a couple of times where we can work out whether we found the target or not. Let's go through this line by line just to ensure there's full understanding of how to use this binary search function. So first we use equal range to find the range of elements equal to the target in our sorted vector. This function returns a pair of iterators representing the lower and upper bounds of the range, and we've stored the pair in this auto variable p. Then we do a check. We're checking if the lower bound iterator p.first is equal to the end iterator of the nums vector. If it is, it means the target isn't found within the array, so we return -1, -1, like so. After that, we're going to calculate the starting and ending positions of our target. Starting with the starting position, we subtract the beginning iterator of the nums vector from p.first. We're storing it in this variable first here. After that, we calculate the ending position of the target by subtracting the beginning iterator of the nums vector from p.second. Again, we're storing this in the variable second. After that, we make sure that the element at nums first is equal to the target. If it's not, it means the target is not found in the array, and we return -1, -1. Otherwise, we'll be returning the vector first, second -1, as the starting and ending positions of the target. So, that's everything. I would recommend that you check out the Udemy course here, and it's also in the description to the video. Dr. Ibrahim teaches this and other problems in more comprehensive detail than I can provide. Now, we'll look one more time at the question and the 4 possible solutions. And yes, we're going to be using the same one, binary search, and the big hint here is the O log n time complexity. And there's quite a detailed explanation as to what we're doing with the binary search here. If you need further help, we have code available in C++, Python, and Java as well. I hope that helps. If you're following us using the learning mode in our application, we'll be continuing with the next problem, which is find right interval. Thanks very much for watching.